Hello, folks. So the time has come. We are finally learning logarithms and how to use logarithms to solve exponential equations and also just solving logarithm equations in general. So what I have for you today is a two-part lesson. So this part is going to be solving exponential functions using logarithms. And then the next part will be solving logarithm equations. So let's get started. I have a document prepared for us that you have access to, and then I'm going to share my screen and we will talk about these wonderful things called logs. Y'all, I love logs. Let me just be clear. I love logs, and I hope that you end up liking them too by the time all this is done. Okay, so first and foremost, the absolute heart and soul definition of a logarithm is that it is the inverse of an exponential. So when you have the most basic, bare bones exponential function in the whole wide world, and that is simply some base, who knows what, being raised to some exponent to make some result. Y equals b to the x. That is the most basic bare bones exponential in the whole wide world. Well, a logarithm is simply the inverse of that. So if you wanted to reverse the relationship of the interplay here between bases, powers, and results, a logarithm will do that. So it's log, short for log, base b of some result is the exponent. So notice the exponent of the exponential is the answer to your logarithm. And the answer to your exponential is the input of the logarithm. They are straight up inverses, y'all. So here's what's really cool is you can use that inverse relationship to solve exponential equations. So check out part A. 2 to what power makes 5? Well, okay, we could certainly estimate. I mean, 2 squared is 4, 2 cubed is 8. So the answer has to be somewhere between 2 and 3. But instead of using guess and check methods, or instead of using Desmos and intersecting this to find out when it is, you can rewrite these three components, base, power, result, in logarithm form. So this exponential statement written in logarithm form, well, the base of this exponential was 2. The result we're trying to make is 5. And the exponent that does that, well, we don't know. That's the whole point. But here's what's neat. Once you've written it in logarithm form, you can just hop on Desmos or a newer TI. Only the newer TIs can handle this and figure it out. So watch this. Let me share my screen again. Only this time, let me move over to Desmos. So to find your logarithm function in Desmos, you have to go into the little keyboard feature and then click on functions. And inside of functions, it's the miscellaneous tab. That is where you will find the log base thing, okay? You don't want regular LOG because that would be base 10 and base 10 only. What you want is the LOG base, whatever. So I'm going to choose that one. And this is where I have control. So what's the base of this log that you and I are trying to solve? Well, it's base 2. What's the result that we're trying to make? 5. And hey, look, Desmos says the answer is 2.32, which makes sense, right? Because we said the answer was going to be somewhere between 2 and 3. 2 squared is 4, 2 cubed is 8. So it has to be somewhere between 2 and 3. And it is, it's 2.32. So it turns out that the log base 2 of 5 is 2.32. And if you think about it, that makes perfect sense because 2 raised to that power should be pretty dang close to 5. There's a little bit of rounding error probably, but it's pretty dang close. For my TI users out there, I don't have a TI on this computer. Hang on. Does this TI have it? Math number, nope, that one doesn't have it. Does this one have it? Oh, this one's dead. Okay, awesome. Well, what you'd be looking for, my TI friends, is if you go into the math button of your TI, what you're looking for is a button that says log base. Literally LOGBASE. If you have a button that says log base, then you are able to do these in your TI. If you do not have a button called log base, then you need to go into Desmos and do it the way that I've shown you in Desmos. If you need more help on that, just reach out to me. I'm more than happy to talk you through that, but my calculator is not new enough. My other one is at home, whatever, long story short, calculator drama. Okay, moving on. So the main thing though, part A, you like that? Part A was so quick, so to speak, because it was already ready to be turned into a logarithm, bases, powers, results. Part B, on the other hand, has all this other stuff. When I look at part B, here's what I'm thinking. I see a base of 3. I see an exponent of x, and I see a result of maybe 30. That's the number that's on the other side of the equal to, so maybe 30 is the result. Okay, but we did not mention the 8. We did not mention the 5. What's up with the 8 and the 5? Well, ladies and gents, the 8 and the 5 are neither a base nor a power nor a result. They are simply extra stuff in this equation. And for that reason, you cannot turn part B into a logarithm yet, because it is not in its bare bones form of bases, powers, and results. So what does that mean? What do we have to do? Well, it means we just have to use regular inverse operations to get it in its bare bones form. So the first thing we can do on part B is subtract 5. Why? Because I can. Inverse operations tell me that it's totally okay to subtract 5. So you have 8 times 3 to the power of x equals 25. Okay. Are we there yet? Bases, powers, and results? No, because what's up with the 8? The 8 is just this, random multiplier in the problem? No, there's no room for random multipliers in logarithm form. So the next thing we'd have to do is divide off the 8. So then it's 3 to the x power equals 25 over 8. You could get a decimal for that if you really wanted to, but I don't know, no reason. Okay, now check this out. 3 to what power makes 25/8? That'd be 3 point something, 3.125 maybe? Whatever, 3 point something. 3 to what power makes that number? Well, I don't know, but that's where logarithms come in. Now that you've exhausted all the other algebra and you feel stuck, that's because it's time. That's because it's ready to get turned into a logarithm. So if you now invert this relationship, invert this relationship into logarithm form, check it out. You have a log. The base is 3. The result we are trying to make is 25/8, whatever decimal that is. And the question is, what exponent would make that happen? And you're saying to yourself, well, I don't know. Yeah, me neither. But that's why you go to Desmos or you go to your newer TI, if you have a newer TI, and you ask it, what is log base 3 of 25/8? So back into Desmos I go. This time I want the log base 3 of 25/8. And it turns out the answer is 1.037. 1.037 is the exponent necessary to make that problem work. 1.037. 1.037. That is the exponent that you would need in this problem. And the logarithm helps you solve the exponent. The logarithm is the inverse. So when you feel stuck solving an exponential, It's probably because you've exhausted all your other algebraic manipulations and you're looking at it, you're like, okay, well, now what? It's probably time to turn it into a log. That's kind of the main theme that I think ends up happening on these. So check out part C. Part C is fun because it's base E. And so that obviously turns into something kind of special that we'll talk about in just a moment here. But when you look at part C, once again, you're thinking bases, powers, and results. And when I look at part C, I'm thinking it's base E. I can see that the exponent is negative 0.23x. And I'm thinking the result is 28. But notice I didn't mention the 5. Yeah, the fact that I didn't mention the 5 means it's actually not ready for bases, powers, and results because it has this multiplier of 5. So for that reason, you cannot turn it into a logarithm yet. The first thing you have to do is divide both sides by 5. Once again, why? Because you can. It's not a base, it's not a power, it's not the answer, it's just a multiplier. So divide it. And you end up with e to the negative 0.23x is equal to whatever 28/5 is. 5 point something, 5.6. So whatever that decimal is. Okay, so now you're looking at it, you're like, okay, the base is e, the exponent is that, the answer is 28/5. Now what? Well, guess what? It's ready. All you have are bases, powers, and results. It's time. It's time to convert this into a logarithm. Now, this one's fun because it's base E, so check it out. You might be tempted to put log base E of the result I'm trying to make is 28/5, and the exponent is negative 0.23x. That everything I just wrote is perfectly correct. Nothing wrong with it at all. In the same token, I can assure you that if you're in a room with people who know math, they're going to look at that and be like, really? Log base E? Log base E? Don't you just mean natural log? Log base E is actually so common because base E is what we consider the continuous growth factor. It's used all the time in nature and sciences. Log base E is so commonly used in the real world that it gets its own button. That's how important it was back in the day when technology was first kind of coming out. Log base E was so critically used that it got its own button. It's called the natural log because it occurs in nature. Base E occurs a lot in nature. So for that reason, you don't have to say log base E, you can just say ln. And what's nice is every TI calculator in the whole world has a natural log button, ln. And of course, Desmos does too. But you can do this either way. And so I'm going to show you both ways so that you can see that I'm not just making this stuff up. They really do both work. So 28/5. Let's not forget that number, okay? 28/5. Back to Desmos. Okay, option number 1. Functions, logarithm, base E of 28/5. There you go. It is 1.7227. That's the answer. Or why would you type log base E when you can just type ln of 28/5? Aha. Hey, look, same answer. Told you, I'm not lying to you here, people. It really is the same thing. They're synonyms. So if you really wanted to put log base E, okay, go ahead. I'm just warning you that your future teacher or a friend or a colleague or a tutor, they're probably going to be like, really? Log base E? Really? You want to do that? I mean, you can, or just use ln. All right. So if you can get comfortable every time you see a base E, I would strongly recommend you just use ln. That kind of proves that you know what you're talking about and you're savvy and you know which buttons to use and when they're appropriate. Okay, so either way, the numeric answer for this is 1.7. I'm just going to round it and say 1.723. 1.723. 0.723. Now check this one out though, equals negative 0.23x. The exponent was negative 0.23x. So even though I finished the logarithm piece of this, the algebra is not done because you do still have to solve for x. You do still have to do that one last step where you divide by negative 0.23 on both sides, negative 0.23. So whatever that answer is divided by negative 0.23 divided by negative 0.23, it turns out the final answer is negative 7.49. So the final answer is negative 7.49. I am running out of room. X equals negative 7.49. That right there is the final answer. All right. So long story short, okay, when you are solving an exponential function, formula, equation, you have to ask yourself, what do I have in front of me? Do I simply have a base, a power, and a result? Because if you do, that means it's time to put it into logarithm form and solve it. But if you have other extraneous parts in the formula that you're looking at it and you're like, like part B, for instance, what's up with the 5? The 5 isn't part of my exponential. It's just like a random plus 5. So yeah, if you're looking at your function and there's other extraneous things besides the base, the power, and the result, then you have to do that algebra first. And then you'll know it's ready when you get to that place where you're looking at it and all that's left is the base power result, and you feel sort of stuck. Well, guys, you're feeling stuck for a reason. It's because that means it's time to convert it. Okay. So hopefully you catch what I'm trying to say there. And once you get in there and practice these on your own, I think you'll see what I mean. I keep saying the word stuck because in my experience, that's exactly what happens. Students will call me over and they'll be like, Bishop, I'm stuck. And I'm like, yeah, you know why you're stuck? Because it's time. You need to convert it. You are no longer able to execute the typical algebraic steps, and it is time to turn it into a logarithm. Go get that answer from the calculator and keep it moving. Okay. So there's the first half of that where we're solving exponentials. I'm going to stop this video and we'll come back and do the logarithm problems at the bottom of the page next. All right. So thank you for your attention. Hopefully it was helpful and we'll be back in just a minute. Okay. All right. Thanks.